Welcome to another informative video brought to you by Autruo. The last time, we looked at ladder programming language. The way this language were used was discussed in detail. Finally, we ended up looking at the unique feature this language has over the other programming languages. In today's series, we will be looking at the function block diagram. The way this language are used during programming will be discussed in detail, coupled with a practical example. Stay tuned. Function block diagram, or FBD as it is mostly called in industries. FBD is one of the most widely used PLC programming languages. It is a simple and graphical way to program A functions together in a PLC program. As one of the official PLC programming languages described in IEC 61131-3, FBD is fundamental for all PLC programmers. To make it sync, let's create one for you to see. We create a conventional start and stop operation, and input and output will be defined as follow. Our start will be 0.0, while stop is 0.1 and the main contactor will be 2.0. The plan is to manipulate the main contactors so that it will only become active when the start button is pressed. Again, it will also be tagged to the other two blocks too. Which means, when the start button is not triggered, B block will not be active. This will be shown in a moment. We will create another block. The main contactor is tagged to address 0.0. The empty sensor, which is the sensor that checks if a conveyor is empty. This will be tagged to 0.1, while the motor ready is tagged to 2.0. Finally, we will create another block which to control the behavior of the conveyor. As usual, the main contactor is addressed to 0.0. The backup sensor is addressed to 0.1. The empty sensor is addressed to 0.2. And finally, the motor is addressed to 2.0. Now we will drag all these blocks to OB1 for program calling. The first block will now be called DB1. The field will address here as the start button is addressed to I0.0, while the stop button is addressed to I0.1. The main contactor is addressed to Q0.0. We will also drag another block to our OB1. We also call this block as DB2. We will also tag the main contactor for each block. The sensor that checks if a conveyor is free is addressed to I0.2. The motor is tagged to Q0.1. The third block, which is the last one, we will also tag this block as DB3. The third block is meant to control the behavior of the motor. The main contactor is tagged accordingly. The backup sensor is tagged to I0.3. The conveyor empty sensor is tagged to I0.2 accordingly. Now let's simulate our program. You will see when I triggered the start button, which is I0.0. The start button that was formerly 0 will now be 1. And the other blocks will be active too. DB2 output will be active. This is deliberately done because I purposely make the empty sensor to be normally closed. Now when I put the missing conditions as per program requirement, suddenly there will be output in DB3. Again, creating a set of instruction in a block and dragging them in OB1 for program calling is not cast in stone. There are blocks that are already configured. Example of such can be seen here. All we just need to do is to drag them. Over to you, Andrea.
Perfect, Laura. Function block programming language is a great way of implementing everything from logic to timers, counter and PID controllers, and many more. It is usually used to describe the function between input variables and output variables. These variables are usually in forms of blocks. FBD are put into function blocks. which usually has one or more inputs and outputs port. The function of the block is the relation between the state of its inputs and outputs. FBD are usually in box form. And in the middle of the box is often a symbol or a text. This symbol represents the actual functionality of the function block. Depending on the function, there can be any number of inputs and outputs on the function block. You can connect the output of one function block to the input of another. This connection will create what is known as function block diagram. There are many standard function blocks provided in FBD. Overall, the output of these blocks are used for controlling valve, measuring fluid levels, motor controls, and many more. Another unique feature is that these blocks can be placed anywhere, because unlike the ladder diagram where the input are usually placed on the left-hand side and the output on the right-hand side, in function blocks, it can be anywhere. Again, with all these flexibilities comes with its own unique drawback. Because the blocks can be placed anywhere, this makes troubleshooting task more difficult and tedious for the engineer. Back to you, Laura.
Perfect, Andrea. Perfect.
Yeah, perfect. So basically, what they did was to put all these code and commands in a box that gives room for input and output termination. Perfect.
Yes, Hendrik. Now let's do a quick recap. We started off looking at function block diagram. A practical example was made on how this language are used during programming. Finally, we ended off looking at its unique feature over the other type of IEC programming languages. In the coming series, we will be looking at the last graphical programming language, which is sequential function chart. The way this language are used will be discussed in detail. Hope you have learned something new today. See you in the next one.